Next, I want to introduce Dr. Gordon Roesler, who is an internationally recognized authority in the application of robotic technologies to space missions. As president of Robots in Space, he provides advisory services in space infrastructure and business concepts to industry, government, and academia with a focus on robotic capabilities, logistics, and advanced missions. So here to talk about the space superhighway. Welcome, Gordon.
Thank you, Casey. Can you hear me? Is that okay? I have to turn my head this way a little bit. Good morning. Thanks to you all for being here. The level of attendance at this is really gratifying. And the quality of the dialogue yesterday in the working group was really gratifying. I mean, great ideas coming up, challenging thoughts, just superb. So I am here to talk about the space superhighway. Thank you, Steve, for handling the information side of this hybrid thing. This is really the hybrid hardware part. This is the hybrid moving stuff around part. So that's, if you want to think about this as dovetailing with what Steve talked about. He's got the information piece and I've got the stuff piece. I am an independent consultant, but I do consult to the Defense Innovation Unit, but these comments are completely my own. One other back reference to Steve's talk, this doesn't have the maturity. I don't have a 21st version endorsed 40-star thing about this. I will say that this concept of a national space logistics system is being discussed at the highest levels of government right now. So we're talking about logistics, right? And I want to start with a Navy quote. Now, a typical military quote about logistics is if you're not thinking about logistics, you lose, right? When General Franks was sitting there managing Operation Iraqi Freedom, he had one screen in front of him, and it was the logistics flow. He knows his people know how to fight. He knows his people know tactics and that sort of thing. He's got to get them the bullets. He's got to get them the gas, right? So here's a logistics expert from half a century ago, Admiral Eccles. Logistics is the bridge between the economy of the nation and the tactical operations of its combat forces. Obviously, then, the logistics system must be in harmony, both with the economic system of the nation and the tactical concepts and environment of the combat forces. So he was thinking back about the logistics that won the wars, both in the Atlantic and Pacific in World War II and the Korean War. So as I look around, what kind of thinking do I see in the Space Force about logistics? Well, here's a good place to look. And General Raymond has said he needs 5 core competencies: space security, combat power, information mobility, Steve, thank you, space domain awareness, and space mobility and logistics, enabling movement and support of military equipment in the space domain from and back down to Earth. This is no longer a nice to have. General Raymond says this is a core competency. We must be able to do space logistics. And even more recently, General Hyten announced the release of 4 strategic directives in support of the joint warfighting concept: joint fires, JADC2, information advantage, and contested logistics. So General Raymond has to think about using a hybrid logistics system, but he also has to think about, what do I do in conflict? How do I make that work for me in conflict? And since there's a Navy quote on here, I'll take a little digression to talk about what the Navy does. So at sea, the Navy gets a lot of its fuel from commercial oilers. So they steam alongside one another and pass wires and pass hoses and that sort of thing. But the Navy also has its own fast replenishment ships. Why? Because one reason is the commercial guys aren't prepared to handle weapons. The other reason is there's times and places where they will not go. The logistics system that I'm going to talk about here is primarily a commercial system, but presumably there will have to be military adjuncts to provide essential services in time of conflict, just to be clear. Okay, Whoops, one too far. So here's a logistics system. The United States railroads as of the beginning of the Civil War, 100% privately funded. Did these have an impact on the conduct of the Civil War? It had an outsized impact on the conduct of the Civil War. Major battles were fought to capture your opponent's railheads and your rail lines. And these were key in the defeat of the Confederacy by the Union. And what were the rail lines there for? Very simple, connect farms and coal mines to cities and ports. That's it, right? That's what that was for. Did the military take advantage of this in time of conflict? Absolutely. So here's another logistics system that we're familiar with. You know what the official name of this is? This is the Dwight D. Eisenhower System of Interstate and Defense Highways. And of course, President Eisenhower envisioned this first and foremost as a way to get military stuff around the country quickly. He was very frustrated as a young officer at how nasty the roads were and how hard it was to move stuff around. But the economic impact of this system is of course outsized. Some little towns disappeared because of the interstate system, but you know, we created the long haul trucking industry because of it. Outsized impact. Here is, you know, the biggest logistics system in operation today, the worldwide shipping system. This ship is about the same size as the one that got stuck in the Suez. 80% of the world's goods move on this kind of a system. And when you think about those containers, and we'll talk about containers a little bit later when we get to connecting with General Santi's comments on modularity. An author of a book about the container says, I won't say that the container created globalization, but I will say that it's hard to imagine globalization without the container, the shipping container. So what does Gordon think we need in order to provide the logistics capability in space that we will need to deter our adversaries and prevail in combat? I think it needs to be a national infrastructure supporting some advanced capabilities, like we've heard people talking about assembly and manufacturing in space, but the same system supports all the users. It supports NASA, it supports NOAA, it supports the commercial communications industry and national security. And newsflash, there's not enough money in the government budget to build this, right? Everyone, you know, NASA, DoD are afraid that this is going to turn into earmarks. All right, so this needs to be, there needs to be new money. Where does new money come from? Well, in the government, it might come from the infrastructure bill. I mean, if all the planets align, something might show up in the infrastructure bill to get this started. But probably it's primarily going to come from private industry like those 1860s railroads, right? But it's got to be coordinated at the national level. And I'll talk more about why that would be. Government, to be customers, needs to put out their needs, their end state goals, but not requirements, not micromanaging, you know, seed funding, advanced contracts, those sorts of things. We want, as someone said yesterday, the language of space to be English and not Mandarin. And we want to see, you know, how does this provide an ability to outpace our adversaries? We'll get to that. It does provide global soft power and influence because, as you'll see, there are ways to bring in new nations that are just getting started in the space into the American system. Unlock value. What does that mean? So someone said yesterday, Jeff Bezos didn't have to invent a transportation system. He didn't have to invent a digital finance system. He didn't have to invent a communication system. He just used those, unlocking the value to create one of the world's 5 largest companies. So Gordon thinks that what we need is a commercial system, but it has tremendous strategic power when you see what it is. Okay, so what do I think it looks like? This is early days in the space logistics system. In the upper left, we already have the beginning. We have Northrop Grumman's 2 mission extension vehicles that are restoring orbit and maintaining position in the geobelt, 100% privately funded. There was not a dollar of government money that went into the development of MEV. And it proved 2 things. Not only did it prove that it's technically possible to do a docking with an operating satellite in geostationary orbit, it also proved that commercial communications operators are willing, and the insurance companies are willing to take the risk of that docking to happen in order to gain the economic value that comes out of life extension for valuable spacecraft. On the lower left is a system that I was associated with for a few years, the robotic servicing of geosynchronous satellites. And another Northrop Grumman asset now that they have become DARPA's commercial partner in this. That will go in orbit, I think it's early 2024 now. I'm no longer associated with that project. But in addition to adding to the life extension capabilities, RSGS will provide the ability to do ultra close inspection using end of arm robotic cameras. It will be able to emplace new payloads on existing satellites, and it will be able to conduct some repair operations, like providing small forces to overcome deployment anomalies and that sort of thing. So on the right are some things that can happen in the very near future. So putting platforms in GEO where payloads can be brought and provided the services that would normally be provided by a satellite bus. So power, communications, pointing and station keeping and that sort of thing. Serviceable GEO assets are coming. Lockheed Martin has announced that their GPS-3 satellites, and in fact, all of their new LM2100 buses will have interfaces on them for both refueling and for electronics upgrades. And if we can take supplies, whether small modules or whole spacecraft, from LEO to GEO reusably, like we're reusing first stages now, there are cost advantages to doing that. And finally, we'll want to see depots out there to provide the propellant that makes, to store the propellant that makes this whole thing work. So this is kind of a mobility-centric view of the space superhighway. I would be remiss if I did not mention Starship at this point. So imagine getting 100 tons into low Earth orbit for very, very low cost. But is there an architecture that needs 100 tons of stuff in a single orbit? If you go back and think about that container ship, that's kind of like Starship. All those 20,000 containers on that ship weren't supposed to go to just that one port. They connect with other modes of transportation to get them all over whatever continent that port happens to be in. So when 100 tons shows up in LEO, you're probably going to need vehicles like you see on this chart to take some of that stuff to other orbits. And that's the way most logistics systems are. They have a multiplicity of transportation mechanisms in order to make them as efficient as possible. Now here's a slightly more futuristic view of the space superhighway. This is a graphic that I borrowed from the NASA DoD On-Orbit Servicing, Assembly, and Manufacturing National Initiative, the OSAM-NI. So NASA has great graphic artists. This is more of a hub-centric view, right? There's still transportation going on here, but the notion is as the space superhighway develops, maybe we need to think about hubs both for storage, but also for hosting, for providing services. And I think it was Eric who mentioned, or maybe it was Bucky, that climate is becoming it was Bucky, one of Secretary Austin's priorities. 90% of what we know about the climate comes from NASA satellites, but every one of those satellites is very expensive. And if we can host them on platforms, we can get the same data at lower cost or more data. So there's a lot of good reasons to have hubs as part of your logistics system. Now, this graphic was developed by government people, right? They're saying, well, we need to have a hub here and we need to have a hub there. If this is going to be primarily privately funded, the private sector, the investors, need to choose the architecture, right? And we at DoD need to figure out how to leverage that. We set our desirements, but not requirements. Okay, so the next three slides are what I would term now a word from our sponsor. So the Defense Innovation Unit has been very forward-leaning in executing projects that support the space superhighway, that are the nuggets of the space superhighway, and will connect to other nuggets like MEV and RSGS. So the first one was orbit outposts. So these are self-contained places where you can host payloads, doing all kinds of experimentation and actual mission stuff. Some of them are launched up there for other reasons, but then provide hosting as a secondary approach. In the lower right-hand corner is the Arkansas port that's specifically designed to receive payloads after launch, integrate them, and provide hosting services to them. So these are moving forward to the next phase after their studies were complete. Then there's multi-orbit logistics. So this is your long-range transport stuff. So there are small vehicles and large vehicles and fuel depots associated with this. And even some lunar payload capability is wrapped up in this. In the newest program, modularity for space systems is kind of the glue that sticks all these together, reducing the cost of space robotics. The robotics are going to be key to moving modules around, right? The standard interfaces. And I want to caution everyone that if DoD says they're setting a standard, they're not. They're setting requirements. The standards are established by industry, right? So we will say we need this kind of thing and we need that kind of thing, and industry will say, okay, here is the standard that we will implement in order to give you those things. And there's going to be a module that actually comes out of this program. We're in the source selection on this, but this will glue together the outposts, the long-range transportation vehicles, and existing stuff like RSGS. So who wants to use the space superhighway? Well, these are the some commercial users that we can think about. Life extension, hey, that one's already happening. Upgrades, going to start happening sooner than you might think. Lunar resources, there are a lot of commercial companies that are looking at that right now. TransAstra, whose CEO is here right now, is one of those. Hosting platforms, I mean, so commercial wants to put payloads up there and they will get fees for people to deliver their components. In space manufacture, whether that's artificial hearts or Z-band fiber, private space stations are going to need things delivered to them. Space manufacturers are going to want to get in flight time to qualify their stuff so they can sell it. And the entrepreneurs that we don't even know what they want to do yet, but they're going to be users of the system. Government, civil government, meteorology. So NOAA has two problems. One of them is continuity of meteorological observations. So the failure of the primary instrument in GOES 17, we'll just move the spare in place, right? That actually costs us taxpayers billions of dollars when they do that. It's not obvious, but it does, right? So that's one problem, is things that break and they want to maintain continuity. But the other problem is they're getting demands for sensors more than they can host on the next generation of GeoBirds. So the hybrid space architecture may provide new ways of putting meteorological sensors up there. Lunar habitats. So Dr. Lal said yesterday that she doesn't think flags and footprints have much meaning, but sustainable lunar colonies, habitats, whatever, do. And we are not thinking very robustly right now about how we sustain those. We're not going to be growing corn and cows on the moon anytime soon. So sustainment still does mean bringing things from the Earth. This architecture is going to have that as a customer. The next in-space observatory, the follow-on to the James Webb, may be even larger and probably won't fit in a fairing. It's going to need to be built, and so the stuff is going to need to be brought there, and this architecture can supply that. Climate monitoring, new ways of hosting instruments, sorry. And NASA likes, one of the best things about NASA is what it does for us internationally. I mean, it even kind of keeps the Russians calm a little bit because they're part of the space station. So being able to bring in new players in the space game affordably using this architecture. Now, let's talk about national security. I hear this phrase all the time, maneuver without regret. I want to maneuver to respond to events on the ground, and I want to maneuver for defensive purposes. And right now, the regret is that reduces my spacecraft lifetime. I've got to be able to fix that problem. I also have to fix the obsolescence problem. Good work being able to, companies being able to develop satellites with 15-year design life. But things change, right? And the same is true for commercial communication satellites, right? We need to be able to change these things more quickly. We need to be able to outpace the adversaries by getting technology in place that is the latest and greatest, but it also solves problems that we perceive along the way. We see a new threat, we design something, we go up there and get it up, and we don't have to wait for the next block upgrade of the system to do that. Shell game, I haven't heard a lot of talk about this, but if we have classified systems, we can move them around, we can put them on commercial satellites, we can put them on hosting platforms, wherever. And by the way, I know this story about, oh, hosting platforms, those are big juicy targets, fine. But if they're also populated by international partners and by commercial things, it does complicate the adversary's calculus. Developmental test, the SERB list is long and things stay on there for years because they just can't get them up. This will help fix that problem. Unclassified, classified satellite. So a lot of the cost of a classified satellite has to do with the fact that you're building it in a SCIF, right? What if you could build 90% of it in an unclassified environment and just plug the classified stuff onto it at the end, right? And reconstitution. Remember, these are all personal opinions. Reconstitution, in my mind, has never been credible because who is going to buy launch vehicles, put them in a barn, and buy expensive satellites and put them in a barn against the day that we have to replace it, right? There is no budget for that. People are not going to do that. But with a robust, rapid, responsive logistics system, now reconstitution after conflict may actually be credible. So 2 takeaways from the customer slide. One of them is there's plenty of customers. The other is these are all stovepipes. Every one of these is a stovepipe. And so when I said that I think this needs to be coordinated at a national level, that's in order to blend these stovepipes, make sure you're listening to all of them, addressing as many needs as possible, both on the commercial side and the government side. So those are the 2 takeaways. And any one of these stovepipes will tell you, yeah, I can do this mission without a national space logistics infrastructure. Sure, any one of them can say that. But how many can say, I can handle 7 of these without a logistics infrastructure? So modularity. General Santee talked about the power of this. He did talk about what I think of mostly as pre-launch modularity, right? More bus suppliers, more payload suppliers, more competition, all good. But let's also think about post-launch modularity and the benefits of doing that eliminating the obsolescence, the outpacing the adversaries. Showed you the picture of the container ship earlier. If you're at all interested in logistics, please read this book, The Box by Mark Levinson. How the shipping container made the world smaller and the world economy bigger. Okay, so what does a space container look like? Well, like this, right? 3 essential interfaces. Hardware interfaces are also information interfaces, Steve. So there's an attachment to the launch vehicle. Could be a light band, could be that this thing just slips inside some kind of a dispenser, but there's an attachment to the launch vehicle. There's a grappling interface for robotics in order to manipulate this module and move it around. And there's an interface to the hosting platform. Good news, some of these are very high TRL. So here's the DARPA Orbital Express experiment of 2007. So we've known how to do modularity for 2007. In the lower left-hand corner, you see a module that was emplaced by a robot arm, taking it off of Astro and putting it on NextSat. And at the top of it, you can see the little ball and stick thing there, and that fits with a tool on the end of the robotic arm. That's TRL 9, folks. And then here is a slightly lower TRL object called the Intelligent Space Systems Interface. It was designed by a DLR spinoff called iBoss. It has been licensed by SkyCorp. Dennis Wingo is going to, with DIU funding, get that up, and thank you, Dennis, for doing this, get that up to the International Space Station and get it flight tested. If you want to transfer propellant instead of electrical signals, there's a couple of things out there. On the left is the NASA Goddard Cooperative Servicing Valve. On the right is the Orbit Fab Rafty. These are somewhat lower TRL, but they're getting a lot of looks right now in terms of on-space utility. So this kind of modularity benefits our supply chain. Companies that do not have the heritage of developing fully integrated space vehicles can still develop space qualified payloads that can go in modules and be emplaced this way. It benefits the industrial base because we can expand the number of companies that are supplying us. Oh, and I said, and the information interfaces. But it may surprise you to know that we don't have to wait until spacecraft have standard interfaces to start bringing the modules up. One of the baseline capabilities of RSGS is to install new modules on unmodified spacecraft. How do you do that? All right. Oh, and this module now, because you can't access the electrical and the data systems of the host spacecraft, has to have its own radio, has to have its own solar power. But how do you attach it? Well, there are at least two laboratory tested, attachment mechanisms. One of them developed by Honeybee Robotics. This is called the Universal Gripper Adapter. That'll clamp onto a Marmon ring, it'll clamp onto a boom, and it has its own interfaces where the electronics payload is attached to it. Another approach is intellectual property of Oceaneering Space Systems. This is a less distinct picture. This comes from their patent. It's hot glue. There are little pads that are heated up electrically resistively. It makes a plastic fluid, and you attach it and cool it down, and it provides a robust attachment of a new module to the outside of an existing spacecraft. So it could be that the first cargo carried by the space superhighway is these modules being brought to unmodified spacecraft. So I thought about who are the people, and I've actually had some discussions with people that are involved in logistics systems on Earth today. What kind of skill sets do we have out there? Planners, schedulers, freight forwarders, analysts, pricers, dispatchers, buyers, forklift operators, estimators, insurers, brokers, inspectors, et cetera. This isn't even a comprehensive list, right? So what are the analogous occupations that we will need to operate the space superhighway? A parallel question is, what are the occupations that we'll need to run the hybrid space architecture, right? Where do we get these people? Now you'll say, well, we don't need forklift operators out there. We're going to have robots. Okay, I guess you'll have to automate those or control them from the ground, which, by the way, we determine in RSGS for dynamic situations is not a good idea. So, and some of these people have intrinsic knowledge, right, that even an AI is not going to help you with. The schedulers, they know how things have to fit together, but it's a subtle kind of thing. Where do we get these people? How do we train them? Mandy Vaughn is very interested in STEM and how we're going to train our future space workforce. If we have a national space logistics system, we're going to have to figure out how we do all these jobs. Okay. The word transformational is overused. I don't believe it is in this case. I don't believe it's an exaggeration to say that a space superhighway, it was said that a USS Space Force priority is to rapidly field agile, affordable solutions to ever-changing requirements and integrate them into open, secure network architecture. This will do that. It will build robustness in the industrial base, leapfrog the adversaries, and take the advantage away from them for decades if we do this. Unlock value, like we talked about, help with growth. If we think we're going to have a sustainable lunar base, we're going to need this. And we'll get our national security applications up there at the speed of need and not at the speed of the acquisition system. So last year, this meeting concluded that we needed a North Star vision for the American space program. I assert that this could be it. Thank you very much.